Hi, Stan. Welcome back.
Hello, Adam. Good to be back.
What I heard is that there was a crowd of scientists who stormed your headquarters and everyone wanted to have a mole house mole bread, right?
Unfortunately, the reality is not as exciting. Things are slow,
Yeah, this is the beginning of the year, They are the crowd of the scientists is forming right now. So this is yeah.
That's the idea. Yeah. But in reality,
What he also told me is
yep.
so you actually tests are a waste of time and the entire CI/CD stuff doesn't work. So you try to build as much as possible on your machine, and if your software, the LC, builds on your machine and nowhere else, it is very good because it can be copied easily, right? So it's like this is like how to call it, a piracy protection built in.
Did I say that?
Only builds on Stans. Maybe this was a hallucination, but this is what I understood after our last conversation.
No, we have like CI/CD set up from the get-go, and in general, one of the early adopters. I started the continuous delivery in my projects in 2012, I guess, and the book was 2010. So, and I used to work as a CI/CD engineer, so
This is why I'm saying this, because you said, okay, CI/CD and unit testing or testing are maybe good topics. And I assumed you are, an pragmatist or scientist, and so yeah, you don't test anymore. You just spend entire time hacking, which is obviously not true.
Yeah. I like when things are tested simply because every time I introduce new people to the projects, they make stupid mistakes because they don't know the project yet. So the tests is a very good. Very good phenomena in this kind of situations.
Okay, so to start the conversation is, let's say we create a complete new microservice. And by the way, you of course have lots of experience with Quarkus right now, right?
Like around 40 minutes experience with Quarkus. Yes. So,
very good. So you tried that. So what's the impression?
Yes. So the first impression is quite good. I really like the simplicity. I mean, the fact that you don't have to restart anything and you introduce changes and it just works, I appreciate this.
Mm-hmm.
There are a couple of things that were surprising. Like, first of all, they use, like, when you add, by default, they have Google Juice and Guava as part of your dependencies, which I found strange.
Google Juice?
Yeah.
CDI? I mean, a Google Juice, I'm not sure whether they have.
I see it like in the list of dependencies. I didn't use the REST Easy implementation, the default one without any suffixes, and it adds Google Juice.
Okay, that's interesting.
I still don't know how well it works on a bigger project, because in my case it was quite fast in terms of reload, but I don't know if it scales.
Yeah. I use it mostly on larger projects and also works great. So it's rather than exception in smaller projects, as my personal projects, and I use Quarkus all the time in bigger projects, and it works well so far.
Okay.
And this Guava maybe Juice is interesting because they have their own dependency injection, and there is Java X inject or Jakarta inject the annotation, and this is API, and Juice implemented the API. But I have to look what he actually did, because it's interesting, and Guava could be. But Juice is less likely. Maybe Guava needs Juice. Maybe this is the dependency.
No. Guava is just utility classes for collections.
Yeah, exactly. So this is why it's interesting case you found. But let's say we would create a new endpoint from scratch with Quarkus. A new project. So we start a new product for LSC. And what you will do? So with testing, unit integration system tests, and what about the CI/CD pipeline? So what is your approach? And then we can maybe discuss my approach and see whether we agree or disagree. This would be interesting discussion.
So if I'm calm and I experience Zen right now and I don't hurry, I would first probably implement the endpoint part and the DTO that I expect on the client side. I will write the test for that endpoint and see that it actually returns the values. Maybe those values are going to be hard-coded first in the
How you call the test?
I would call it, let's say I'm adding, I don't know, endpoints for users.
Yeah, was it the unit test, integration test, system test? How you call it? Which category of test is it?
The first one, I call them component tests if they don't run against the real environment with the HTTP. If it's like internal method invocation, then it's component test. If it doesn't even need the contexts like load the beans, if it just calls the classes and methods, then I call those unit tests. And the system
above
tests
component tests,
those are system tests because they require the whole system to be deployed.
Very good. So the system tests, I also call them system tests. The reason being is because I found years ago the definition on Wikipedia. It's okay if there is something defined somewhere, so I will just pick it. But system tests is not that common, interestingly. So for me, it is system tests, always was. But I found end-to-end tests also sometimes. There's they talk about end-to-end tests. Component tests is a good one. I call it integration tests, also because of Wikipedia. But component tests I like better because it will fit better my BCE model. But I call it IT integration test. It's also how it's defined in Maven. And unit test is unit test. It's just basically we are testing a single method, right?
Well, yeah, ideal. A method or multiple methods.
Ideal. But it could be more, but usually it has to be fast and not too much of Quarkus has to be started, right?
Yeah,
so usually... If I have a unit test, I think in recent years there was no dependency injection involved. So this is usually no dependency injection.
Yeah, that's my also. I don't know how you came up with this terminology, but yeah, that's my terminology as well. And in terms of terminology,
my technology and terminology usually is based on someone else's books or standards, Wikipedia. And the reason being is I'm consultant. If I do this, I don't have to discuss a lot with other consultants. If I would introduce my own names, I would spend endless meetings and documentation. And the cool hack with that is I don't have to argue a lot. And I also don't have to document a lot because everything is already documented. So just, use some pointers, links. And in worst case, I copy over some concepts and I'm done, basically. That's the idea.
In terms of terminology, testing doesn't have the stable terminology anywhere. There's like ISTQB thing that is more like manual testers know about these. There's more. There's this book with the terminology, but it also has some very weird definitions. And a lot of people, call things integration tests, and for them, almost everything is integration tests. But I prefer to think of like if we're thinking about integration between systems, then that's the only thing that you cannot not call integration tests. So I prefer to call that integration test only for integration of the systems.
That's interesting because integration test is more like you integrated one class to the other. So for me, an integration test, according to Wikipedia and my terminology now, but I looked up Wikipedia a long time ago. Maybe it changed already, so we have to revisit that. But the idea would be an integration test would be a test where you're already using dependency injection, for instance, but you are just starting parts of the system. Let's say typical test is if we have persistence JPA. I would just use the JPA without anything else, just talking to database or JDBC without launching the entire Quarkus, parts of the Quarkus in my project. This would be an integration test, less common nowadays, because what I usually have is a lot of system tests and some unit tests and integration tests area.
Mm-hmm. Well, then how do you call tests that check the integration between two systems?
Yeah, this is still a system test, because one of the systems is the master system. This is what makes the application. And if I call this system, it will call the other systems. So for me, it's not a lot of difference, because if there is no fine-grained microservice, it ships with system tests. And if as a bigger microservice, it also ships with system tests. But if I call this service, it calls other services behind the scenes. So in my world, there is no integration, just system tests.
Well, I definitely make it more granular, because I can, and I did in the past, we had system tests that integrated with mocks, not with the real dependencies. So we would not call those integration tests. So those were system tests because they needed the whole system deployed, but they were functional tests, because they were, the goal was test the functionality, not the integration between multiple systems. So this is a matrix to me. One says we have levels, how much we need to initialize in order to test. Those are unit, component, and system tests. And the other axis of this matrix is what we want to test: functionality, integration, performance, maybe something else.
Mm-hmm. And the integration tests in my world is also was borrowed from Maven, because there's this Maven fail-safe plugin which defines, how integration test behaves, and this was also the integration tests which run from inside. And the system tests are also driven by the fail-safe tests usually, and they end with IT. So my system tests end with IT, integration tests, and also with IT, and the unit test with test. So this is important later for the CI/CD pipeline. It happens automatically, but
Yeah, but
and interestingly, I try to completely avoid mocks. I think for the last 4 or 5 years, there were no mocks in my projects. So there's absolute exception from the rule.
Yeah, same for me. We have maybe a couple of tests with mocks, but overall, no.
And this is interesting, because a few years ago, there was obsession in projects about the mocks. So they believed, that there is a unit test and the entire environment has to be mocked out. And what I saw projects with unit tests, lots of unit tests, great code coverage, lots of mocks. And the problem is they had no idea whether the system is actually working. So everything was green, but they had no time anymore to have, the proper system tests.
Yeah.
Or they would have time, but the problem is the management insisted on code coverage, which was measured at unit test level, and they were only interested in the numbers, in the statistics. So they got the numbers, and there were no system tests, which is crazy in microservice world, but is, I would say, more common than you may think, actually.
I remember the days, like I was one of those people, I don't know, 15, 18 years ago. We had all sorts of tools, measure coverage, all unit tests, almost like 100% coverage, branch line coverage, everything. But yeah, I dread those times.
It's your fault. This is what I saw in projects. This was your code, maybe.
Yeah, there were times, but now I don't even measure coverage. I think this is
very good.
This is something that spoils the quality of tests, because if you give people a metric, they will find a way to get the numbers right, but they stop thinking about what's real, what's just for the sake of management.
Cool anti-pattern in this case is to use reflection to invoke as much as possible during unit tests. This was also what I encountered in projects. Now, all getters, setters, everything was invoked, because code coverage means not verification or assertion coverage. It's just what you call during the tests, which is amazing that someone measures that, because it's not even what is tested, what is called during the test, right?
Yeah. In general, I look at the test coverage. The usual test coverage line in branch coverage is it shows what's not covered in tests, but it doesn't show you what's actually covered. Only that the fact that this line was hit. And if we're
Mhm.
serious about testing, we probably should think about mutation testing and check the quality of the tests, not just that the test hits a line.
Mhm. But back to coverage, what I do sometimes, if we have system tests in place and you run your system with code coverage under system test, then it is interesting because if you called all the external API and lots of code is not called or not used behind the scenes, it means probably that is forgotten code. So maybe this is a candidate for deletion or pruning. So I like to use code coverage to get an idea what could be possibly deleted. So it is a little bit dangerous because this code could be used once a quarter or whatever, and not during
Mm-hmm.
the by different actors, like for instance scheduled jobs or whatever. But at least it gives me an idea. Okay, this code is not important enough to be run during the API tests. So this is actually a good tool to have.
Yeah. Yeah.
And now mutation testing. This is interesting because this is really interesting because this is a bit crazy. So there's a tool called PyTest. And this PyTest does the mutation testing. And what PyTest does is it during the tests, it modifies the business logic with the expectation that the mutations or changes have to be caught by your assertions. But if your assertion is just, assert not null, nothing gets called. Assert not null is very common, and assert true is the other one. And if you have proper assertions, they should verify the results, not just whether the result is available, right?
Mm-hmm. Yeah,
You
that's
use mutation tests a lot in your system?
no. We like I experimented with this, but it required so much energy that
Exactly. It is slow because it mutates the business logic. It can be really slow. Mhm.
yeah. So if you're really into quality, then yeah, you should. But I guess most systems that we build, they're not. They're fine with the tests that we write.
Okay, so we have unit tests. We have the system tests. What's interesting is you described your way. You started with system tests.
No,
This is also what I
component
do.
tests. System test is
Component test.
running against the environment, and
Uh-huh.
component tests runs locally within. So if we were to use Quarkus and we would invoke the endpoint, that invocation would not involve any HTTP. It would call the Quarkus endpoint directly. Like in Spring, there
That's
is mock
interesting.
MVC, and that mock MVC accepts the URL, but it actually invokes it directly without HTTP. And therefore, you have all the nice stack traces. If something fails in the test, you see you don't have to dig through logs of another JVM to see what was the problem. You have the stack trace right away. You can debug it easily. You can step through in the same process. So those are what I call component tests as well.
That's interesting because in Quarkus, the library is called rest assured. So this is what allows you to directly call the endpoint without going via externally. And this is the
So
first dependency which I delete.
so
If I start a Quarkus
rest assured is originally is the library that allowed you to write system tests specifically to send the HTTP queries.
Mhm.
Later, they added the way to integrate with mock MVC so that you still write the rest assured, but it's possible that it invokes the endpoints methods directly without HTTP. And I guess they may have integration with Quarkus to do the same, but I don't know.
Yeah, this is if you create a Quarkus project with Quarkus. There is a CLI called Quarkus, and you say Quarkus create app. This is what will happen. You get the rest assured dependency with two IT classes, which test greetings, which is like a demo there. And the first thing I do, I delete the rest assured and all the tests. because I test differently. This is the first difference between us. What I do is, let's assume our project, the name would be, what we can do, we do chemistry. So we have a chemistry module. Then I would create immediately, I would copy chemistry to chemistry ST. And this would be another Quarkus project with the only purpose to call the first one. And I won't use the any framework, specific framework. I would use the production thing, which could be microprofile REST client or HTTP client, Java 11 plus HTTP client, to write the tests to go against HTTP. And the next step would be to create CI/CD pipeline, which automates that. So the Quarkus will be built, unit tests will run, integration tests will run. Then the Quarkus will be deployed somewhere in production-like environment. All my projects are in the cloud right now, so it is production-like. It is 90% now is Quarkus on AWS Lambda. So this is not problem at all. So it is production because there's no difference between development and production Lambda. So there's a Lambda, and the system test will call the Lambda. So I would say in the first 2 hours, end-to-end tests, I call it system tests. And then I'm confident that, okay, now I can call it. And, because what I expect problems is, recently, for instance, I implemented an MCP server, and the problems were, of course, HTTPS, because the environment wanted to have HTTPS. So this is problems I'm expecting, not necessarily stack traces, whatever. This is usually infrastructure problems, networking, IP, DNS. This is what can bite me, because I'm as consultant in so many environments, and every environment is a little bit different, firewalls or whatever. So this is my order. And usually I won't have any unit tests at the beginning. None. It would, because I write the first unit tests if some complexity is there. So if there's some more complex code, a little bit algorithm or whatever, non-trivial, string manipulations, this is a big thing because index or whatever, or regex, this is where I will for sure write always unit tests, but not at the beginning.
Okay, so my approach is whenever you're test functionality, I would first start with the component tests, and then to test infrastructure, I would add a health check endpoint right in the app. And after every deployment, I would call that health check endpoint, and it may invoke some other services if needed, but it's going to be one endpoint to test everything, and it returns 200 if it's okay with additional nice data. And I try to stay away from HTTP tests that test functionality, simply because in my experience, for me, it's enough to test on the component level, again, invoking those endpoints, but directly without the HTTP. And the health check is what checks the infrastructure.
In my project, I have another problem with that, is that we are supposed to have multiple versions in production. And you have the two modules, you can easier test that. So what you can do, you can say, okay, I check out all the system tests which run against the newer module and see whether it's still working. So backwards compatibility is fairly easy if you have two modules. But this happened in recent years. So there are more, either we had to use external specifications or we create a product with various versions against, and other clients are using this. And this was a nice way to do that. And but I started with a system test before that. And the reason being, back then was, we have microservice architecture, which means share nothing. And the question is how much I need to invoke this service successfully. And the idea was, it was JSON and HTTP. So the question was, how much do I need on the other side to do that? And this was more realistic approach. And it comes, I spent sometimes as firefighter in projects where sometimes, they had memory leaks or whatever. And the system tests is a good starting point to create a stress tests. Because if you have a system test which calls from outside your endpoint, you can implement a stress test which does it in a loop or whatever. It was fairly easy to to modify the system test to get a little bit more reasonable testing on the load. Because what I wanted to verify back then is, connection pool setup. What happens if there are not enough connections? How the server reacts? How the error looks in the logs? For instance, to like maybe like
stress testing,
stress testing, chaos testing, to see what happens if we just, and of course whether the metrics are working as well. So otherwise you have no idea whether what happens, how the basic metrics are working.
Yeah, definitely. Yeah, I like the fact that we don't write system tests. We write them, but not for functional tests. We write the performance tests. Those also go through the HTTP. Yeah, but I think in general, when people try to come up with best practices for testing, this is the worst thing, because we should look at testing from purely pragmatic standpoint. If it helps, if it saves us hours and improves quality, then that's the approach that we should take. If it doesn't help, then don't do it. Like, I don't know, people come up with rules. Don't test via private API. Don't just check through the public API. Like, even if you write unit tests, that rule may be true in some situations because you don't want to rewrite the test when the private things change. But it may also help you in other situations where this code is very complicated and you do want to go internally, and it will help save time simply by going through the private API. Like,
recently, we even introduced a private API just for better testing.
Yeah.
I can give you an example. For instance, if you have, let's say, this was a serverless project with Lambda, and we needed a way to verify whether the state of the system changed. So what we did, there was a private API only available during tests where we can access the bucket directly, for instance, right? So it was
exactly.
And with that, we can prove that actually something happened. Otherwise, you would rely on public API where maybe fetch data from bucket is not even available. Because if this is like an audit Lambda and it just writes to the bucket, you cannot just, and this private API was fairly simple. You can just publish another Lambda or another microservices with the access, which is not available in production, so it's even safe. So I'm with you. The problem I have is if you would like to write good software, you don't need any best practices. You only need ideas. You can do this. You can have system test, stress test. This could work. This doesn't, and you do the right thing. Unfortunately, in larger projects, it works a little bit differently. So a client hires a company, and this company hires another freelancers, and then the people come and go all the time, and they are only interested in the contract. And if you ask them what this software is doing and why they are there, they maybe not even know, what the killer features of the software are. They have just the Jira tickets, and they work with the tickets one by one. And if they are done, they are done. And in such environment, you have explicitly tell them, we have to do this. Otherwise, you get nothing. Nothing which is in contract will be done. This is strange, but sad but true, I would say. And I also saw such a project, and in this project, it was more like cover my ass strategy, which is not in contract, not be done. So the contract became more and more complex, which led to more and more strange things. Like, if there was 80% code coverage in the contract, you got the 80% code coverage, but maybe the software didn't even start it. And the funniest anecdote was at the beginning of Java. I was in a huge German company, and they implemented one of the first internet systems with Java. And in the spec said there was this is an internet application, but it was implemented with a single thread. And I asked him, look, we are in the internet, right? So, one thread is not enough. It should be multi-threaded, because if there's one user is there, it's in internet, the other cannot wait. And they listen to me and then ask me, but point me in the specification somewhere where they are demanding multi-threaded application. If there is no such requirement, we will not implement it. This is like, so I agree with you. If you build your own software, I'm completely with you. We need the ideas and exchange, our experiences and done. But if you're larger projects, and I ask, what's your opinion about microservices? Okay, if you take microservices seriously, we need system tests from outside without any dependency to the microservice as additional documentation. This microservice requires this data structures to operate successfully, and you need a strategy for versioning. What we do is versioning, is this like tolerant reader, or we have multiple versions of the endpoint, and so you need some. Every decision has some consequences. This is and you have to know the consequences up front.
But the problem with the contractors is not the size of the project, right? Facebook is writing a huge project, but it's just, why do you hire these people, right?
Yeah,
because
exactly.
It's their job to think about multiple threads, not the person who writes the requirements. And
but this was a long time ago, right? So this is like 1997, but it was funny, This is like a
just
typical
in that spirit.
Now it never happens again. I don't think now someone will try, to create a single-threaded internet application. But back then was a typical conversation. Now in other cases, and yeah. Mm-hmm.
I'm using this as just an example. The fact that some people write 80% coverage because it's written in the documentation. This is another of such examples where, like, this should not be part of the requirements, and you just need to hire good, high-quality contractors. And the reason we have contractors like this is because it's more political, because people who hire them as well are thinking about their own metrics and covering their asses and not about the quality of the products. So within the companies who hire those contracts, there's also a lot of rot. But that is more political than
it is political.
Technical.
But it is, I think the existence of some patents also political. It's not like we need such patents to write great software. It's more like we need some patents to be politically correct, right? So I don't know whether you remember a few years ago, it would be impossible to be depending on one database. I remember, I didn't want it to have the DTOs and DAOs, and I say, you cannot do this because otherwise we cannot replace Oracle with DB2. And I said, okay, how likely is it that during the project you will replace your database? And more likely is that your database will outlive your application, actually. But it was no way around. Actually, one point I started to write funny blog posts about that because it was ridiculous. In some projects, no kidding. In one project I showed, I forgot the exact number, but it was huge. More than 30%, I remember, code was just DTOs and mapping. So this was just pointless, empty code with nothing. Then copy one object and it comes to another object which is identical to the first one, with the hope in one time one of the project will change, because they could decouple from everything, but it was always the same. This was the strange part. And then they used specific frameworks, Dozer, for instance, which was able to map the entire thing one-to-one. And then Dozer is end of life, and now they have a problem, for instance, right?
Yeah, the Dozer times are super weird. But still, they have this new Mapstruct, which is the same thing as Dozer, but different name. But people are spending so much time doing basically nothing. They transform data from one format to another format, while they could have just returned this format in the data in this right format right from the database.
Exactly. You are doing this, so you are accessing database and you are returning from a database what's needed to the front end.
In many cases, yes. We sometimes map things to the DTOs directly to return to the front end. But more often than not, in these days, we just generate the JSON in the database because Postgres has a good JSON support. So we just generate that string. It either is returned as a string or as a map, and then that map can be transformed into JSON.
Mm-hmm. So you're using JSON.
Saves a lot of time. Yeah.
JSON-B.
Well, JSON-B is the storage of the
Yeah.
columns
Yeah.
in like the way you store the data. But
Mm-hmm.
even if it's not JSON, if it's just columns, when you do the select, you don't have to return the table. You can't. There is an option to return a JSON, and you just say, "Here's the name of the field. It comes from this column."
That's cool. So you're using a Postgres capability to generate JSON, and you are returning. You get already JSON on JDBC level.
Yep.
That's cool.
Yep. I really like that.
That's a cool idea. So what I usually did, I mapped as early as possible to a simple DTO. Now it will be Java record. There's no reason to call it DTO anymore because it's just a record. And then on the other side, just serialize it with built-in capabilities of Quarkus with JSON-P or JSON-B to JSON. So this was, and what I usually had, the record had a method to JSON. And this was my mapping layer. So I could actually say what is serialized and what's not, and this was good enough, right? And I already had the mapping layer because this was T2 JSON method, and I still got some criticism. And there is no mapping. It's like, how much would you like mapped? So it mapped from database to record, but your idea is even better. So you don't need the record at all. You can just return JSON. So this is actually, I like it.
But I have to there are situations where it's a search query, right? The only thing that you need is to return the data from the database. But there are other situations where you have like RESTful endpoints, put, post, get, and it's the same JSON structure. In those cases, we do create a DTO, and because we reuse that DTO for different things.
Is this Java record,
validation.
the DTO? Nowadays?
No, we just create classes with public fields.
But it could be record now, right?
So records adds the hash code and equals and the public getter setters, which I think all are useless for DTOs from that perspective.
Now you are even more pragmatic than I am. So because I also use the public DTOs often, but now I like records. But you're right. You could say the classes with public fields are even leaner than Java records because I don't need the hash code whatever. But I like the records how they feel because it's a single line, so it is less code. So what I'm interested in nowadays is, just I don't have to look at too much code. I like how concise Java can be. This is what I enjoy a bit. But even more interesting, so I had a conversation with Thomas Wirtinger of GraalVM on the recent podcasts. And what they do on Oracle database, they can run the GraalVM images inside the database. So they can have stored procedures written in various programming languages. And what in this turns everything around. So this cool story is then you could consider the database as your cloud. Because what they also can do, they can register triggers. So if someone writes a note to a table, they can, in database, an event is fired and the GraalVM wakes up and processes that, which is code. GraalVM is can be Java, is Python, can be JavaScript. And on the other way around, what Oracle ships with is REST endpoint, which points directly to the database. And what you could do is you can move the entire logic to a database. I just find it interesting because this is extreme. This is complete opposite what usually happens in lots of projects. Projects would like to see the database as a dumb data store and don't use any features. So you said the JSON, which is actually an interesting feature, but going completely wild. I would say there's nothing against writing the entire logic in the database, data gravity, near the data. And in the Oracle case, there's Oracle Cloud. If I would be a client and I have an Oracle Cloud with Oracle database, and the Oracle database is replicated, this is like complete different programming paradigm because I could have two regions. I write to one database and it replicates with the other one. So there are complete new possibilities. And I don't have to bother with the infrastructure. And I need the database anyway, right? So that's the cool story. It's not like you have to install database to run your business logic. The database is already there, so I can just deploy the business logic to the database.
So how does it work in practice? Like, what steps do you have to do in order to use this capability?
The GraalVM.
Yeah.
This GraalVM is the image which deploys, and there's this is more or less stored procedure in Oracle. It only works with Oracle right now,
Mm-hmm.
and there are tools where you deploy the GraalVM images to a database. And back then, I tested similar technology in 2000s, so very early. And Oracle had the Aurora VM, which was not that good. And back then, you could already write Java stored procedures. But
Mm-hmm.
GraalVM is completely different level because they start in milliseconds, and they will also kept warm. So I can listen to the one of the recent podcasts about GraalVM with Thomas Wörtinger, which is a team lead of GraalVM. And if you're interested, just ping him. So they are really eager and really nice guys. So they will also be on Joy Focus, a conference,
Mm-hmm.
and in Stockholm. So, but I find interesting concept, because what is also fascinating is that if you have one pattern and do exact the opposite, you get another best practice. So it is always problematic if you are in the middle, because you have the worst of both worlds. But
Yeah,
if you have
exactly.
consequent, then just do it, right?
Yeah. Yeah. I think those days, like we had probably in the 90s when the database was the main part and most of the logic was there. Then things changed and someone said that should be the opposite. And now I think we're returning back to those times where
Yeah,
people know
stored
that base
procedures
is
were
better. And
were forbidden, and
yeah,
then
for a
it was
long time.
crazy anyway because we had the relational database, and it's okay, this is just the data storage, and business logic is somewhere else. Stored procedures are not allowed, and this was highly transactional database. Then we get NoSQL with and the argumentation back then was that SQL is way too complicated. You only need a hash map. You can mapping by your own, and you don't need transactions because NoSQL back then couldn't deliver transactions. And they say, look, there are so many MySQL applications without any transactions and PHP, and we don't need transactions. And then was full circle back. Then NoSQL got transactions, and now NoSQL, all databases I know have SQL or SQL-like syntax, and now it turned out SQL or SQL is actually very good. And transactions are also good. So now the NoSQL databases are almost SQL databases after years, and it converged. So it means all the extreme ideas, this was the problem. They were pointless. So at the end, we are almost at the beginning with different technologies, some more products, but most of them was a marketing gig. Actually, if you think about this.
A lot of technology stuff is marketing and hype,
Mm-hmm.
but there are, of course, good reasons to use NoSQL databases as well,
Yeah.
because SQL databases implement all sorts of stuff. They're the safest, the most functional thing that exists. But what if you don't need all of that stuff? Maybe you can squeeze out extra milliseconds out of every request just by abandoning some of the stuff. And that's when you want to look at the other databases that.
Yeah. But this was not the milliseconds were never the argumentation, because at the beginning Oracle was crazy fast. This was the problem. It was fast, and the argumentation was we don't need this performance or not this consistency. But looking at the feature of Postgres with JSON-B, we are almost NoSQL, right? So you can
Yeah,
use
yeah.
yeah.
There are, of course, like limitations. Like if you have a real document database, it's created for that thing. So there are
Mm-hmm.
certainly cases where it would be faster than Postgres, but you need to understand in which cases. And default should be have one database, don't overcomplicate things. And when you see there's a complication, you cannot overcome it, then think about other infrastructural pieces.
So how many pipelines or CI/CDs do you have in a product, or if you don't have, how many you would like to have, or what would be the ideal process? There's
And
always
each
shortcuts. So mhm.
each project has a simple pipeline. Things are first built, the image, Docker image is uploaded, then we deploy automatically to the dev environment, run the health checks, start performance tests, and then it goes to the environment where some other environment where testers maybe are involved. And then the last thing is deploying to production, which is manual step. But that's
And
outside of the
the
pipeline.
production deployment, how this happens? Is this a new CI/CD pipeline or is the same?
No, just QA knows the version that they need to deploy. They open a separate job for the deployment because Jenkins doesn't have the nice support of manual steps. So this has to be outside of the pipeline, but that's more of technical difficulty. So they just know the job. They go and manually insert the version and it goes to production.
And how it's deployed? By Jenkins. So Jenkins picks the version, deploys to production.
Yeah.
Yeah, that's cool.
Or I guess there are two choices. And the simplest choice is Jenkins does the SSH to the machine and starts the Docker container there. But from the security perspective, we don't really want Jenkins to go to production because Jenkins is very vulnerable. So we just wrote a very simple, you know how Nginx and Apache, they can run the shell scripts. So through the CGI, I think it's called. So we wrote some shell scripts. We created some Nginx password protected, and it calls the endpoint on the Nginx, and that starts the bash script.
What could be also an alternative is that your production environment asks the Jenkins, do you have something new to me? That you reverse the dependency.
But it's already reversed because Jenkins only says, hey, deploy. But then it's the production system that goes and figures out where to get the data from, etc. It's just this ping with the version information that happens through the Jenkins. Polling is also probably a possibility, but of course, it would have to pull from somewhere. So it's another piece that you need to implement, where to poll and how to recognize that the new version is ready.
Back to health checks, because it was not the right time to talk about the difference, because health checks actually make in my current projects no sense. Absolutely no sense. And the reason being is, if you think about Lambda, it only is active or lives for the duration of a call. If I call the Lambda, it's alive and then goes away. It means if I would expose a health check and call the health check, the Lambda will wake up and goes away. So I only know, for the duration of the health check, the Lambda is operational, but I have no idea whether it's operational after the health check because the Lambda will be started on different machine. So this is like stateless environment. Nonetheless, we still have health checks. And the reason being is because the health check is not Kubernetes health check, but the health check is more for us. We know we have defined endpoint. I can call, the endpoint, and the health check provides me additional information. So it's not like in Kubernetes that if there's 200, I know it's alive, and otherwise it get restarted. It's more like a human can call the health check, and if it's not 200, we know it's something wrong with our business logic because that the Lambda fails is almost impossible. So I don't know any occurrence where the Lambda didn't start it because of infrastructure.
Well, you may set up the database connection correctly, right? Or the contract between your Lambda or another application may not be the same. So in the health check, what I would do is check the connection, check that I can send some simple requests to another service and get the answer. And if not, then I would get the not 200 code, and that would be a health check failure. But it's not for Kubernetes or Docker. It's for whether the infrastructure is set up correctly and the connectivity between services is.
In all non-serverless project, it is, in my case, for Kubernetes or Fargate or something similar. So we have two health check, liveness and readiness. And it's still not that easy. Forget serverless. Let's go with Kubernetes. And what I think a common mistake is if you have a liveness check bound to a database and you say the database is not there, what Kubernetes will do would kill you and restart you, but it doesn't get any better because this database is still not there. So with the liveness, a little bit cautious. The readiness check is usually for load balancers. This is more interesting because you say if the database is not there, you don't get any traffic, which makes more sense. In Lambda case, we still use both. And liveness is more for humans. I can ping the service and see whether DNS is in place. Can I call the thing at all? Because it can happen because of misconfiguration. I have the wrong URL, for instance. And the readiness is, for instance, availability of secrets, of configuration. Is the deployment in the right state? But for the readiness, is still hard enough, to come up with good use cases. So what I remember recently, we had readiness to check whether the cross-account permissions are set up correctly. Can I actually access? We wrote a dummy object, to the S3 bucket. Is it possible from the permission perspective? And stuff like that. But I think, and if you in projects, back to big projects, political projects, liveness and readiness probes in 90% of our cases are completely empty. So it means if you call it always green, whether the database exists, no one cares, right? So this is yeah. But if you are serious with that, I think it should be also part of the system test to call the thing and see if you get a right response, then you proceed. Otherwise, you can stop right there, right?
Mm-hmm. Yeah. So we have a similar idea. Is one of the endpoint is just /version, and that returns the version of the application and some other meta information, but it doesn't go to any database. So that would be called first by the deployment scripts, and if that passed, it means the container or the process started, and we're ready to do the health check and check the database and other services.
Where are you running? Are you running in your own data center or in the cloud or?
Hetzner.
Hetzner, cool. So German company.
Yeah.
And you provision the Hetzner automatically or?
We just bought some virtual servers and use most of the stuff is there. We don't use the virtual the cloud, the new thing that they introduced a year ago. Well, not more than a year ago, right? The year ago they introduced their own S3 storage, so that's what we actually use.
Hey, cool. And you use the official AWS SDKs or something different?
I think so. There was a choice, right? IO or something, and then I think it's AWS, which is very heavy, unfortunately. But yeah. So yeah, I really like Hetzner.
On AWS, you can make it lighter. I don't know whether you know with the SDK, because if you do nothing, you get all the clients. You have to exclude the clients and only include the URL connection. Then it gets lighter. So you can inside the SDK say exclude Apache or whatever. This is all the clients which you don't need the HTTP clients. You usually only need the URL connection clients, which ships with JDK. So the entire shipment will be lighter.
I see. So let me see.
So this is, I expect an email from you with the explanation how lighter it got, but it is usually allowed because all the Apache, Apache HTTP client and whatever are not shipped anymore, just URL connection, which ships with Java.
Yeah, I see that we added. It's actually not as heavy. It's only one dependency. It's probably maybe I confused with Python where it loads a lot of dependencies. So it's S3. No. It's a bunch of AWS dependencies after that. Yeah.
But you can make it lighter by excluding clients you don't need.
At some point, yeah, we'll have to check. It's another. I think it's with Google Cloud as well. Also, all you need is maybe coldly storage, but it loads 20 megabytes of dependencies. It's horrible.
Yeah, but because it's a completely different world. I can explain you my pipelines on AWS. There's no Jenkins, for instance. There's code pipeline and code build. There's like serverless. They wake up and do something, and you configure this with YAML. And what usually happens is you have private repository, usually GitHub. There is an AWS app in GitHub. You set up I think it's called Source Connection. A Code Star is the product name. And it points to GitHub. And this is the only thing which is not automatic. All from there, the entire infrastructure is provisioned with Java. So we have the CDK, Cloud Development Kit, and we code the entire infrastructure. And the first thing we deploy are the pipelines. And the pipeline wakes up, and the CI/CD pipeline is what we described. So it builds from Maven, it runs the unit tests, and then it uses the CDK to deploy the Lambda in another account. So this is the first difference. So we have CI/CD account, and the Lambda runs somewhere else. The system tests get the freshly deployed Lambda, and this is like generic or dynamic URL. This is ugly, but it's good enough for tests. So they call the URL and see whether it is working. If it is working, so what I do is I create the zip and push it to a S3 bucket, which is versioned. So we have all the version of the software. So the zip is in the bucket, but now it's the difference. The bucket emits an event, put object event, which wakes up another pipeline. And now we are integration stage. So it's from there we have no code, which is driven by events. And now the entire security and roles and permissions are inside the S3 dependency you saw. So this is why they are bigger, because the IAM STS, this is like the short-term user credentials. They are all in the dependencies, and this is why they are bigger. So because the concept is different, the entire security, they are, for instance, in the entire cloud, we don't have users, we have roles, which are short-lived. So if the pipeline calls something, the credential lives for 15 minutes and then it just disappears automatically. And this is multi-account environment, requires specific permissions and SDKs, and this is why they are bigger than outside. Because I think if I would implement, or if you just call S3 bucket, the call is SIG v4 with HTTP it is signed, and there's one library which does nothing else than signing, and this is just signed with the role, and on the other side the role is decoded, and we see AWS sees, okay, are the permissions right? And the entire mechanism is in the SDK. So this is why they need lots of dependencies, and they try to keep them low, but this is how it is.
Yeah. When I tried to do similar things like the CDK stuff, the deployment, the automatic deployments, it took me a lot of nerve, and I don't want to go back to AWS.
No, you don't have to. But if you have another 30 minutes, you can take a look at cloud constructions.cloud. So I have our view. This is my website. I publish the typical setups from various projects, and it's growing and growing. And constructions.cloud, and this is all CDK. You can just look at the code, and I like the code actually. It's shareable. It's a simple, type safe, and with that, I'm actually fairly fast. I would say, like Lambda with Quarkus, deployment is matter of minutes, and it is without any clicks in the console. And yeah, but it's a different story.
You mean every deployment is minutes, or the first setup?
The coding and deploying. The deployment, the pipeline, usually how long? With all the system tests, 15 minutes. Average, if you take average.
That's why I don't like the AWS. It's so slow.
No, but the pipeline, I don't think it will be any faster outside of AWS, because my system tests are HTTP, right? So I'm calling from outside, and there is lots of tests. This is complete build system tests, and almost until production is realistic. So we have usually hundreds of system tests, and there's HTTP calls, some cold starts maybe. So this is what it is. And in some projects where we have lots of tests, it was half an hour, the entire process, which I think is too fast. So we could speed it up a little bit, but it was without any optimizations, half an hour, all the tests, the entire pipeline from checkout from GitHub until production, half an hour, which I think is okay.
We'll have to.
1 minute will be better. I agree with you, but yeah.
Mm-hmm. Yeah.
We covered a lot. There was not a lot of disagreement, I would say, unfortunately. I thought there would be more fight.
That's why we need
where people can buy
streams.
LC, Molwerks, and all the shiny toys from LC.
Where? On our website.
Yeah. What is the website? What is the URI?
lclsci.io. And that's our, yeah. But I don't think your audience, a lot of them are scientists.
Who knows? There are lots of developers in different areas. So who knows what happens? Thank you a lot, and see you next time. If something interesting happens, you are on the Hetzner cloud or you reduce all the dependencies, just ping me and we can record another episode. Thank you a lot.
Thank you. Bye-bye.